Look at this box placed on this table. We want to make this box move over this surface. What measures should we take? Well, we know that when we want to make this move, we basically want to change the state of inertia of this body. That means it is now having an inertia of rest, we want to bring it to inertia of motion. In the process, we really need to take the help of an agency that can bring about the change in this state of inertia. Now, this agency, in a way we are familiar with it, in a way we can know more about it through this simple exercise. Normally, what happens, if we want to make it move, we can apply either a push to this body. I am pushing it towards right, so it moves like this over the surface, or we can do the same thing by, that means we can make it move by pulling it like this. So, once again I can push it from this side and bring it towards left, and we can once again pull it and take it towards further left. So, to change the state of inertia, we have really taken the help of either push or pull, and in the process we have observed what has happened. I hope you have now observed what are the two agencies, or rather one single agency that gets manifested in different forms. The agency that is responsible for bringing the box to motion, or the same agency can make one moving body to stop. You must have read or gone through Newton's first law of motion. Newton gave us these laws of motion, 3 laws of motion, some 300 years, more than 300 years back, and this first law tells us that to change the state of inertia, we really need an agency, and this agency is known as force. Now, push and pull, whatever we talk about, are essentially forces that bring about these changes in the state of inertia. Moreover, when a body is moving uniformly, if we really want to change that velocity, either increase or decrease, once again we need the help of force. So, these push and pull are essentially the forces that are bringing about these changes. Now, for the application of push or pull, we really need to make use of our muscle power. This box is a light one, and it may appear that we have not really applied much of muscle power, but you can understand that when we are using in place of this box, we are using a heavy box and maybe pushing it over a floor, rough floor, we need to apply a lot of muscle power. In fact, sometimes we are unable to do that work. And these push and pull, when we apply them, we must be in contact with the body where this has been applied. So, push and pull are quite often referred to as contact forces. Naturally, you can see until unless I push it, touch it, I come in contact with this body, I cannot push it, or until unless I come in contact with this body, I cannot pull it. So, push and pull are contact forces. Now, the point is, do we have any other form of force apart from these contact forces? Those can bring about the change of the state of inertia of a body. Well, let us see. Now, suppose I put this box on a different surface, and what I do is like this. I go on tilting this surface, and we see that this box is moving. Now, I am repeating the exercise and try to observe whether there was any contact with anything that made this box moving. You please observe it again. So, the box really can move without any contact of anything, so to speak. That means, without an application of a contact force, this body can still move. And in this case, it is obvious that the force of gravity has pulled it along this inclined plane. Now, when it is being pulled along this plane, of course, you can, when it is being pulled along this plane, we can apply a force against its motion and can make it stop. But this force I have applied is a contact force, whereas the force that was pulling it down was the force of gravity, and that was a non-contact force. So, not only the push and pull, but there are other forces that can really make the, that can bring about the change in the state of inertia. Of course, you can understand there are non-contact forces that include the magnetic forces, and since this being a plastic box, a non-magnetic box, we cannot expect magnets to pull it. So, what we are doing? We have taken a piece of iron ring and we are allowing a magnet to pull it, and let us see if it can. This magnet is having two poles, one pole on this side, the other pole is on that side, other side. I am bringing it close to the ring, and let us see what happens. You have possibly noticed that the ring moves towards the magnet when it has not touched the magnet. We can show it again over here. The surface is slightly different, but the entire thing remains the same. You can see when it is the magnet is brought closer and closer to the ring, at a certain point of time when there is still a gap, the ring starts moving towards the magnet. So, this force that magnet applies to this magnetic material is once again a non-contact force, because the force comes into play before the contact. Similarly, we can expect the non-contact force between the two charged bodies. We talk about electrostatic charges and attraction by the electrostatic forces. We shall be able to show it to you. And you can also see that these non-contact forces of gravity that can work like this. I can really drop this ring right over there, it will come down to my palm because of the pull of gravity. So, you can understand the non-contact forces we are really familiar with, the gravitational forces, the magnetic forces and the electrostatic forces. Of course, in a way gravity is very considerate. Gravitational force, you know, the entire solar system, that is the planets, they are moving around the sun under the pull of gravity, sun's gravity, the mutual gravitational force, and number of satellites of different planets, they are moving around the planets once again because of this pull of gravity. The gravitational pull is so well known to us, we sometimes tend to forget it, but we have to remember that this is a very familiar and very engulfing non-contact force. I hope you will appreciate that in SI system of units, the unit of force that has been derived from the name of Newton. In fact, the unit of force is called Newton, and when we are writing, of course, the force, we write it as with a small n, and this refers to the unit of force. For example, if I talk about 5 Newton, I am talking about 5 Newton force, and symbolically, of course, the capital letter N comes as the symbol for Newton, and this also refers to 5 Newton force. Whereas, if we write this to be like this, then this name, this essentially refers to our good old scientist Sir Isaac Newton. Forces are observed, or we come across or encounter in our everyday life in so many situations. You will be able to know more about the forces and their effects and the roles they play in different everyday life situations. You will come across them in a number of situations, and in the second part of this talk, I shall be talking about some aspects of force, once again, that are very much familiar with all of us and that we come across in our everyday life. Thank you.